In this video, we're going to see how many drops does it actually take to break water surface tension with isopropyl alcohol. So the goal of this experiment is to actually see how many drops does it actually take to reduce the surface tension of water from just using rubbing alcohol. Usually, a lot of people would use surfactants or basically soap, but we just kind of want to see with a different liquid to kind of reduce the surface tension of water. In this figure, you can actually see that we're going to be using a paperclip, a glass of water, a pipette with rubbing alcohol, and of course, rubbing alcohol itself. The materials used for this experiment are water, isopropyl alcohol, food dye, a digital scale, paperclips, and tweezers. There are two procedures that I did to conduct this whole experiment. I'm actually going to be talking about what I did to actually get a mass measurement for a single drop for each of the liquids, for water and rubbing alcohol. The first step that I did was to reference the 1 milliliter mark on the pipette and count each individual drop of liquid. This was to help reference out how many drops are in a single milliliter, rather than counting every single drop of liquid into a cup to obtain a mass reading, which is pretty tedious. Once I'm able to get my 1 milliliter to number of drop values, I'm able to draw in more liquid, such as 3 or 4 milliliters, and dispense it into a cup and obtain a reading for its mass with the digital scale that I do have. With the reading of the mass, I would be able to know how many drops are there by conducting the math to obtain the amount of grams per drop value. As you can see, I was able to obtain the calculations for the single drop of liquids. I did obtain the surface tension from an online source, as you can see from the reference link on the bottom right corner. The paperclip's mass was obtained by using a digital scale. From using 2 paperclips, I was able to get a reading of 1 gram. Then dividing it by 2, I was able to just get a single mass for 1 paperclip. From using Newton's second law of motion, I was able to obtain the weight of a single paperclip, in which I'll show the final calculations toward the end of the video. Next up, we're actually going to be conducting the real experiments. For this case, what we have to do is actually fill up some water, in a clear cup at least, with some food coloring. Then we would have to stir it up nicely to allow the food coloring to actually settle evenly before the experiments. Then we'll also fill a small cup with the alcohol and add food coloring too. Also, the most important step is to actually place the paperclip very, very carefully. Kind of like so, right here. Then to step 5 and step 6, which is to use the disposable pipette to add the drops of alcohol into the water. And then we would have to kind of keep track of how many drops we're actually putting in to the cup of water to allow the paperclip to actually sink. From actually replaying this video many times, I did get a count of 13 drops into the water. On to the results and discussion. So I did actually measure the cup with a ruler for the diameter, just so we can initiate the calculations for the force of the water, along with obtaining the surface tension of the mixture, as we did apply 13 drops of alcohol. As you can see from the force of water, it's pretty high, as you can see, of 0.0163 newtons. And getting the surface tension of the mixture, it does look pretty similar to almost to what the alcohol surface tension was. So as you kind of can see, the paperclip did go underneath the interface of the liquid, which kind of shows that the surface tension did decrease as you did apply 13 drops of alcohol onto the interface of water. To wrap up everything, 13 drops, which is equivalent to 0.26 grams of rubbing alcohol, was able to reduce the surface tension of water at its interface. Another thing to consider is that since nothing is perfect, a major thing that could have affected my results was from not considering each single drop of liquid, as there could be some uneven drops that do have different masses. Thanks for watching the video, guys. Stay safe and stay healthy out there.